Now another method is the parallelogram method. And of course, in two-dimensional orthonormal system, we have just to recall some geometric laws, which are the law of sines and law of cosines. The law of sine says that in a triangle which composes three angles and three sides, sine alpha sine alpha over the side opposing it is equal to sine beta over the side opposing it is equal to sine gamma over the side opposing it. Yani they are proportional. And concerning the law of cosines, it says that a c squared is equal to a squared plus b squared minus 2 times a times b cosine gamma, which is the angle between a and b. Similarly, a squared equals b squared plus c squared minus 2bc cosine alpha, and b squared is a squared plus c squared minus 2ac cosine beta. These are the general laws of sines and cosines in any triangle, not only in, you are used to trigonometric relations of cosine and sine in right triangle, which says that cosine is adjacent over hypotenuse and sine is opposite over hypotenuse. That is only for uh, special triangles, which are the right triangles. Now talking in general, for any triangle, not necessarily a right one, the law of sines and law of cosines are as follows. And I just want to here note that A, B, and C are the length of these sides. So here we have to determine the resultant force of two force vectors F2 and F1 of magnitude 5 Newton and 8 Newton respectively by using the parallelogram method. How can we make use of that? The point is that in the parallelogram method, uh, the adding two force vectors, the resultant force is the diagonal of the parallelogram having these vectors as sides. So as you can see here, we are given that the angle between the two forces is 105 degrees. Alpha, which is the angle between uh, alpha, which is the angle between the force F2 and the opposite to F1. So we can obtain it by subtracting 180 degrees minus 105 degrees, because we know that same side interior angles are supplementary. So that's why we get that alpha is 75 degrees. So now how can we make use of the previous laws in this parallelogram? It is as follows. Fr is the diagonal, and as if we are talking or dealing with this triangle, for example, and we have that this is F1 and this dotted one is actually opposite to F2, so we can consider it to be of magnitude F2 or of length F2. That's why applying the cosine Fr squared in this triangle, مثلا, for example, it is equal to F1 squared plus F2 squared minus 2 F1 F2 cosine the angle between these two sides, which is alpha. That's why we needed to calculate alpha here. Then Fr squared is equal to 68.3, and then we need Fr, not Fr squared, so we have to square root it. And in mathematics we say plus or minus, but however here in physics actually it's wrong to say to take magnitude alone as negative, so it is positive in magnitude. Applying law of sine, we can also consider this triangle and say that sine A is over A equals sine beta over B sine C over C. In this case, it's sine alpha over Fr, which we are looking for, is equal to sine beta over F2 is equal to sine 75 over 8.26. So these equations, solving this equation, the only unknown is sine beta, so we have sine beta is equal to 0.584. Shift sine 0.584 on the calculator, we get the beta angle.